I'd like to welcome Joe Caserta, who is going to talk to us today about building a big data landscape. We are really excited to have him here with us today, and without further ado, I'll turn it on over.
Hi, everyone. Everyone hear me okay in the back? Good. For those of you who don't know, it's like two bright headlights staring right in my eyes. So if I'm squinting, I'll be looking this way a lot. So we're going to go over big data and what it means, what it might mean to the landscape and how it affects Humana. Over the next hour, we'll talk very briefly about before big data, traditional data warehousing, and then how big data is affecting the landscape within the data warehouse ecosystem and within the company itself, and how it's going to penetrate pretty much every application and start to really get integrated, if you let it. Dealing with Hadoop, and we'll cover all of the basic concepts and try to dig really into the weeds as deep as until I start seeing heads go sideways. Then I'll back off a little bit, but we'll start very, very high level, and then we'll dig down as low as we could all tolerate. We're going to talk about some kind of non-technical things, but very, very important things like data governance. When you get all of this unstructured data into what we're now affectionately calling the data lake, right? The big Hadoop cluster. What do you do with it? How do you control it? How do you define, what a member is, what a provider is when you have all this unstructured data coming from all different sources? So that's pretty important. We'll also talk about master data management, which I think 2014 is going to be a big transition year for master data management. The way it's being done traditionally really is not going to be effective anymore once you go into the big data paradigm. And then data quality as well, when you're getting unstructured data from sources that we can't necessarily control. How do we ensure quality? Just a little quick qualification of myself. So I've been doing software development and dealing with data for about 25 plus years. I wrote the Data Warehouse ETL Toolkit with Ralph Kimball about 10 years ago. Started a big data practice in 2009 and launched a company that we do nothing but big data solutions, data warehousing, and business intelligence for 12 years now. Some of our clients, we have a lot of healthcare experience, a lot of insurance experience, a lot of financial experience. Mostly, we're based in New York City, so that's what's up there. We do have a little bit of manufacturing and retail, but it's not really applicable to you except for some of the MDM concepts and data integration concepts are all the same. This year was kind of, it's last year now. We got voted to be one of the top 20 most promising data analytics consulting firms in the country, which is kind of exciting. So, data is not a new concept, right? We've had data since the beginning of business. Started off with, ledger paper, and then it switched to spreadsheets. Then it switched to mainframe applications. Then it switched to client-server applications. And through the evolution, some companies stayed ahead of the curve, and some companies stayed a little bit behind the curve. And if you look at the success of companies on a day-to-day basis, you'll see the ones that really embrace innovation are the ones that are always the ones ahead, right? And now, more than ever, where there's just so much data and we have so much real interaction with our customers, right? I'm sure, when's the last time anybody in this room actually met one of your members? Never, right? So how do we deal with them? How do we know what they want? How do we know their behavior patterns? Right? The only way to do it, the only way to really understand our business is through the data that we collect about it. And without that, we're doomed. Right? So So within the past 2 years, the IBM statistic, 90% of all the data in the world today was collected in the past 2 years. And that's not going to stop, right? The volume of data that's being collected is it's unprecedented, and it's growing exponentially. And the existing systems that we've been working with for the past decade or 2 decades just are going to stop working. So we need to do something. So we need to actually embrace some new technologies that we're going to talk about now. So this has been my world since 1996, right? We have your traditional ERP systems, claim systems, finance systems, enrollment systems, and then ETL is my sweet spot. That's where we get all of the data. We clean it, conform it, consolidate it, put it into a unified structure, and then we do traditional business intelligence reporting. Some canned reporting, some self-service, ad hoc reporting. But now, we're getting data that's unstructured. We're getting data that we can't control. We're getting external data, internal data, being created by machines, not human beings anymore, right? We're getting weblog data, system data, call center data, call logs, text from speech to text translations, so we can do sentiment analysis and understand if the customers are happy or sad or mad or angry, right? And then we're getting all of the social data. What does society really think of Humana? How do we gauge that? Are they talking about us in a positive sense or a negative sense? So we get all that data, and we're bringing it into this new paradigm. The new paradigm is affectionately called big data. Doesn't necessarily have to be big, though, right? We've done Hadoop type of implementations where there's not, the volume issue isn't really the problem. It was really more the variety of data. When you're getting data that's unstructured, where you're getting all different types of attribution, all different types of levels of granularity about a member or a customer or a product. Bringing it in and then doing some machine learning and science on your data. And what we're calling here, part of this is what we effectively call the data lake. That's one of the new terms that you may or may not already heard. And the line could not be in a worse place. But there's a couple of components that's in every big data solution. MapReduce, when you're speaking to Hadoop, MapReduce is the language where you actually manipulate the data and actually analyze the data. And it's a language where it builds mappers, right, where you can actually find the data and make sense of it. And then reducers, where it compresses the data so that you can analyze it. And then you have Mahout, which is machine learning. That's a library of algorithms where there's just too much data for human beings to actually do analysis themselves nowadays. So Mahout is a set of libraries. We use Mahout pretty much every project where we need to build a recommendation engine. So recommendation engines are kind of like Amazon. If you like this product, you might like that product. Recommendations have different use cases. Finding the best, recommending who may be the best call center agent may be for a particular customer, or what ticker an investor might want to invest in based on his past performance and his peers' selection. And then Pig and Hive. For those of you who are the programmers in the room, SQL developers, Pig and Hive, that's the way we actually do our new big data ETL, essentially. We're doing our data transformations and data manipulation. Pig is a programming language, and Hive is essentially, for those of you in the business intelligence world, where you build semantic layers to try to simplify the complex databases underneath. Hive is kind of like that for big data. Hive applies a structure to all of your unstructured data. And Hive is affectionately called the data warehouse of big data. Personally, I think Hive is probably the worst part of the big data paradigm. It's incredibly slow, incredibly inefficient. But this year, at the end of last year, the concept of Hadoop 2.0 came out, or Big Data 2.0. And with that, Hive is actually, it's much, much, much faster, much, much more efficient, and there's many more new technologies that are embracing Hadoop 2.0 so that you can do distributed queries where and apply indexes to your data. Also, what we're finding now is we're doing ETL, we're getting data not only from this unstructured source and large volumes and variety of sources, but we're getting all of your enterprise data. It starts off because in order to put context around this data, you need reference data. So you start off just bringing in reference data, and then once you have the reference data and events within your big data solution, you start asking yourself, why do we still need the traditional data warehouse? And we're finding that the big data paradigm is really starting to become the hub of the company for analytics, and in some places for transactions as well. For a lot of the startup web.com companies, they don't even really go with relational databases. They go NoSQL databases and Hadoop. And the relational world is really getting left behind in a lot of the startup companies. So once we have all of the all the unstructured data, all the structured data, all the system of record or gold copies from the warehouse, we bring it in. We're doing data mining, right? We're doing machine learning within Hadoop. We're gleaning insight out of our data, and now we have answers. For now, what we're doing is we're actually sending those answers back to the warehouse. And the warehouse is really just becoming like a presentation layer, right? All of the heavy lifting and all of the ETL is being done in Hadoop. And then all of the presentation and all the reporting is being done up there in the traditional data warehouse. So your Natises, your Teradatas, right, your traditional data warehouse appliances are really now limited in scope to just doing queries with the end users. And that's only because all of the BI tools need to write SQL, right? Once the BI world expands and the BI world can actually, one of two things has to happen. Either the BI world has to start speaking native to Hadoop, either through MapReduce or something else, or the NoSQL databases need to evolve and start being SQL compliant. And that's really happening today. So with tools, there's a couple of distributions of big data. Cloudera is one of them. They came out with a NoSQL database called Impala. Impala speaks SQL. There's Hawk, which is by Pivotal, which speaks SQL. Cassandra speaks CQL, which is very, very much like SQL. So now that the NoSQL databases are starting to mature a little bit, we're going to see more and more BI tools that are ready to speak natively to the big data cluster, and then the traditional data warehouse and traditional BI reporting. This time next year we'll probably see a lot less of it. Maybe. There is one tool here that today you can speak natively through a pretty nice interface. Looks a lot like Excel, does pretty good graphics. Not crazy sophisticated like Tableau, but pretty good to glean insight. And it could go against native Hadoop files, and that's called Datameer. They're a vendor out there. One of the leading vendors that you don't really need to put it in a NoSQL database or any kind of SQL-like database. Here's some tools that you may want to do some investigative research on your own. Kafka is a messaging queue. Mahout is the machine learning language. Hive and Pig languages, if you're dealing with big data, those are kind of like, it's like dealing with relational databases, you just have to know SQL. If you're dealing with big data, you just have to know Hive and Pig. Scoop is for getting data in and out of your big data solution. Zookeeper is just for administration. And then Storm is for real time. So that's for ingesting, streaming data. So if you're getting data from a message queue, like Kafka, you can bring it into Storm, and Storm can do ETL on the fly. In Stream, do data manipulation, and then write it out to Hadoop, or write it to a NoSQL database. The kitten really has nothing to do with this presentation. But it's statistically proven that if you show a kitten, the presentation will be successful. And it's a cute kitten. So we have NoSQL databases. I mentioned this a few times already. There are essentially 4 types. It's not a one-size-fits-all. If you're dealing with data in a NoSQL environment, MongoDB, we call that the gateway drug to NoSQL. Most people, they have very, very strong marketing. Most people who are diving into NoSQL world, Mongo is like the first one you deal with. It's pretty easy. Couch is one of its competitors. Graph databases we're going to talk about a lot later when we talk about MDM. Graph databases is essentially how Facebook says, you know, if you like this page and your friend likes this page, you know, the chances are that your other friends might like this page, right? It's all about relationships between objects and people. And key value pairs, that's pretty self-explanatory. You know, that's very semi-structured, I guess. You know, you have a label that says this is a name, a provider name, and then you have the value that says, okay, it's Humana, or not a provider, you know, ABC Hospital. Then you have columnar databases. And columnar databases are basically key value databases, but they have this concept of column families, where you're actually, so column families are essentially tables in logical tables. And Cassandra and HBase are probably the most popular columnar NoSQL databases out there today. HBase comes with most distributions, and the distributions are on top. Cloudera, MapR, Hortonworks, and Pivotal are probably the top distributors. If you do, this is probably a good time to talk about it. If you do want to start playing with Hadoop, at the end I'll put my website up there. We actually have a free, fully baked Hadoop setup on a VM that you could just download. It's like 3 gigs, 2.5 gigs, something like that. And you could just download it and play with it. It has most of these components already installed, configured, up and running, and you could just open it up and start playing. Python, Java, SciPy is just a library within Python. That's it. So why are we doing this? Why do we really care? What is the benefit of actually taking all of this data that we never had before and trying to make sense of it? I have my own personal mission on why I'm doing this. About 4 years ago, my father got hit by a terrible disease called progressive supranuclear palsy, PSP. If there's any clinical people in the room, they'll know what I'm talking about. It's a pretty rare disease. Dudley Moore is the celebrity that had it. And part of the disease is he would fall all the time. And every time we'd go to the hospital, I had to be there because at one point he couldn't speak anymore. And I had to tell his story over and over again. Like, they never knew he was on blood thinners, they never knew his history, they never knew what medications he was on. They didn't know anything about the disease. And other people who had that disease also were going through the same experience. And there's no treatment and there's no cure. So there is an organization called I forget exactly what they're called, but there's an organization around PSP and trying to help it. And every time I'd go to the hospital, I'd say, how could you not know this, right? It's data. It's all about data, right? And being able to share data and being able to analyze the data to try to progress medicine. I think it's a mission that I just decided to do when I became the primary caregiver for my father. So this is something that's very, very near and dear to my heart. And I feel like that if we can get the data right, and I know a thing or two about this, and I can help, that's why I want to do this. And I think if we can get it right, you know, the insights that we can glean out of this stuff is very, very actionable, and we can all really make a difference. So what are the challenges? Like, why is this so hard? Right? Data is data. But it's really not data is data. There's basically 4 categories on what makes this thing so interesting. One is the sheer volume. You know, we have one of our clients is a bank. We're ingesting 1.2 million transactions a second. Every second, we're getting 1.2 million transactions. It's volumes that are completely unheard of. 12 billion transactions a day, every day, 12 billion new transactions. So, you know, there's no relational database that can do that. Right? There's no ingestion system that can do that. Right? But we're doing it using Storm and Cassandra and Hadoop. And then the variety of data, getting all of the different disparate data sources that is structured, unstructured, trying to make sense of that. And then, you know, trying to govern all of this data that you have no control over. Right? The big thing about data governance is it's all about control. It's about putting accountability for the people who are creating this data. But if you're getting this data from different sources, how do you put governance on that? So we're going to talk about that. And then also, a lot of this data, it's kind of being manufactured, right? So how do you know, one of the questions we put is, how do you certify the quality of sentiment analysis, right? Like, how do you know a phrase is positive or negative, you know? You know, there's lots of, what's the one? I'd love to kill somebody, right? Is that positive or negative? You know, so, and then the velocity. So it's just when we want to do things real time. Right? One of the other things about the data warehouse is it must be complete, right? You have to have all of the data in. It's one of the data quality tests, right? Is the data really complete? Well, if you're receiving it in stream and you're doing analytics on the fly, real time, right? If you're getting a call and the conversation is still happening, but you want to start making sense of that conversation so that you can apply action, how do you apply governance to that? When is it really finished? Right? These are just questions and issues that we never had before. So that's why governance is really, really important, and it's very, very different from the way we've been treating data in the past. And again, these lines could not be in a worse place. So there's basically 7 different pieces that need to happen in order for data to be considered governed. And this is in traditional world and big data world. Doesn't really matter. But, you know, you need to have the people. You need to have the organization of an enterprise data council and data stewards. And you need to be able to provide a catalog to your users to say, this is actually what the data is, and this is what it means, regardless of where it's coming from, and regardless of how fast it comes, regardless of who created it. It's really no excuse. If we're presenting data to our users, whether our user is a business group or a data science group, we need to be able to let them know exactly what they're looking at. We need to ensure quality. And this is something that's constantly changing with this new paradigm. The concept of, you know, sitting it down, running tests, doing some ETL, fixing it, and then loading it to the warehouse. When we're getting data at such extreme velocity, we need to come up with a different approach. And we'll talk about that too. Data integration, dealing with different sources and different targets. Master data management is also going through an evolution that we'll talk about. And then information lifecycle. Once we get it, what do we do with it? How long do we need to keep it? How do we archive it? Talk about the cloud a little bit. So before we had data warehouses, right, the challenge was data was not conformed. You had people making spreadsheets, coming into meetings with different answers to the same question, right? And then we put in a whole bunch of rules, and now we have a nice, hopefully governed relational world. And now with big data, the promise of big data is that it's so big that we can just ingest everything. There's no such thing as, with the data warehouse world, we spend a lot of time assessing value of every attribute and getting business rules before it comes in to make sure that, that we don't create what we call Swiss cheese data, where there's holes in the data. But now with Hadoop, we just bring everything in. So there's basically two rules that we want to apply. Right? Dumping data into Hadoop with no repeatable process procedure or data governance, you're going to create a mess. So we want to try to avoid that. So we want to put some governance around this. The second rule is information harvested from ungoverned systems. They're going to take us back to the old days, to before we started. So we don't want to do that either. So we need to come up with a new process. We need to make it right. Unfortunately, this space of making the data right, getting the data in and manipulating the data, that's maturing every day. The process and the concept of making the data right is extremely immature in this space right now. There's a tremendous amount of opportunity. For anybody in the room with entrepreneurial spirit, this is the future, right? So there's a couple of steps we want to do. Establish the difference between traditional data. If you have an existing data governance program today, you need to understand the difference, and then you need to fill that gap. Right? It's going to take, a change in mindset, a change in culture, change in process, organization, and also change in technologies. Processes for graduating the products of data science to governance. We'll talk a little bit more about that, how the data scientists are actually going to help us make sense of this data. We'll talk about the big data pyramid, where we start with just collecting everything and then slowly but surely, through a couple of steps, applying fully governed environment that users can use in the big data paradigm. And then make a set of tools. Everything must be automated. There's just too much information to have any manual or human intervention at all. So we have to change the organization and the process. We have to change master data management program that we have today, if you have one. We'll talk about graph databases for that, especially. One of the biggest challenges usually with master data management is managing hierarchies. Hierarchies within a rigid structure, relational structure, it's been attempted for decades. It's really not easy to do. Graph databases makes it a lot easier. Metadata, there is no single metadata solution for this yet. It's going to take a mix of some new products that are kind of in the incubation stage, some more established products that come native with Hadoop, and then a lot of homegrown, roll your own type of metadata solutions. And this is how it looks. So when we get our data from all of our different sources, right, raw machine data, collecting everything, we're putting it into what we call the landing area, the big data landing area. This big data landing area is going to take all of our source data and in full fidelity just bring it in and leave it as is. That's step one. When we do that, we will have some governance around it. Right? Since we are writing programs to ingest this data, we should understand what it is. Right? So we should have at least a metadata catalog that says this is the information that we've just consumed. And then the ILM, right, the information management, lifecycle management. So we should also know how long do we need to retain it, Do we need to purge it? Do we need to save it, right? Is it under HIPAA regulations, right? Whatever the management side of this data is, should be known at this point. Then what we do is we go through an ETL process, right? And we start turning this data more into information, right? It's very organized, well-defined, maybe not fully structured yet, right? Still going to be unstructured, still maybe moving it to NoSQL databases, NoSQL databases. And now we're going to have some data quality and monitoring on it. That's the new. So from here to here, that's the big difference, is now the data is going to be pretty sound, right? We'll at least be able to fix it and make sense of it, or at least be able to tell you what's wrong with it. And then from there, then we'll have data scientists actually start attacking that data. And the data scientists are going to apply machine learning, some data mining, some predictive models, and the results of that will be stored in this data science workspace. So now we have enriched, clean data in the cluster. And then from there, then and only then do we take the golden nuggets out of our data and we apply it to the masses. We unleash it to the masses. And the big data warehouse that we're calling it is the tip of the triangle is a fully governed environment.
You're fine on time. I actually have a question from online, if you don't mind.
Sure.
And I apologize to the person who asked it and to you. I'm going to try my best to pronounce what I'm seeing in front of me correctly.
Yep.
What is your view on the new SQL movement? Solutions like Clustrix, NuoDB, or Translattice are offering scale-out capabilities of NoSQL world combined with transactional security over big data sets.
It's a good question. Clustrix is essentially, it depends on how you define big data for you on the phone. Big data doesn't have to be Hadoop. To me, big data just means distributed computing. If you're distributing your processes and your data across commodity hardware, that's a big data solution. What Clustrix does, Clustrix is basically MySQL that is distributed. Instead of doing sharding, it's actually distributed across a cluster. I have not implemented Clustrix yet, but from what I hear, Clustrix is actually really good. Depending on your use case, Clustrix might be a great answer. One thing that we'll learn is the concept of polyglot persistence. There's a guy named Martin Fowler who came up with this term. What polyglot persistence means is take the mentality of being a one database shop, like I'm an Oracle. This is an Oracle shop, or this is a Microsoft shop, or this is a IBM shop. And think about every use case on its own and figure out what is the best solution. And if the best solution is a distributed relational database, that's great, do it. If the solution is something that's maybe more of a key value, what happened? That is not me. Whose computer is this? Okay. So the volume, right, that Clustrix is able to handle it solves part of the problem. But if one of your problems is that you need to be really agile, say you have an e-commerce site where you're thinking of new attribution to collect every day, right? And so in that case, Clustrix probably wouldn't be a great answer, or any SQL-based database probably wouldn't be a good answer. You probably want a key value NoSQL database so that you can just on the fly add this new attribution, and it'll just start collecting it without going through an IT project to go and add the structure of a column to a database. And I can't see his face or get any feedback, but I hope that answered his question. Any questions on this, since we're doing questions? Yes?
You envision those bottom three layers as being into HDFS, HBase Hive, and that top layer being an RDBMS?
That's a great question. So the question was, do I envision the blue to be Hadoop, and then do I envision the yellow to be a relational database? Today, yes. Next year, maybe, maybe not. I think that is the one part of this paradigm that still needs to mature some. There's new initiatives out, Impala, Stinger, what's the other one? Help me out here. I don't know, but it is maturing, but it's not great, to be honest. Putting that in something like a Netezza or a Teradata or Greenplum or whatever, right? Some kind of relational MPP, right? Massive parallel processing database. That is what we're doing today. Yeah. This time next year, probably not. A lot of words, sorry. So, just to go back for a second. So there is governance, right, throughout the entire life cycle of the big data paradigm, but only the top big data warehouse could be what we call fully governed. And the reason for that is to be fully governed, you really need to have structure. You need to have structure around your data. So right now we're doing Hive tables or Impala or relational databases for that top piece. We must have metadata. We must have known certified data lineage. So exactly how did that data come? Where did it come from, and what do we do to it between A and B? And that all needs to be in the data itself and queryable and accessible to your users. And also, we have to govern the usage. So now that this data is available, who's allowed to use it and when? And each one of these will have a different set of users. And we need to be able to govern that. It's not that, data is only by a single BI tool. We used to have, everybody has to go through business objects. Otherwise, you don't get access. Those days are over. We just need to be able to control it. Yeah, that's it. Okay. So, data scientists. Any data scientists in the room? Sexiest job in America? So data scientists, they will be able to help us, because if we go back here, in order to have the top fully governed, we need to be able to make sense of this data. So the data scientists, I just want to jump ahead, I'm jumping around a little bit, but the data scientist, what does a data scientist really do? The notion of a data scientist, we always think about, at least I always think about, it's a very, very sexy job, right? It's the guys who are super smart, very brilliant, and they're creating these incredibly sophisticated algorithms that are really going to change the way and change the way the business works and really be pivotal in their findings and how you apply that to the business. That, for the most part, is true. But really, they spend most of their time just munging data. Just, first of all, trying to find it, right? They're asked a question, and which data elements and which data sets are really going to answer this question. And it's trial and error. They don't really know, right? Because they're always charting uncharted territory. So constant data munging, making sense of the data, figuring out how it looks, why it looks that way, getting rid of all the junk, right, that all of the systems are creating. Perfect example you could probably relate to. Every time you load a web page, right? You want to understand all of the real activity on that web page. If you ever look at a web log, 90% of that log is just loading image files. So the first thing we do is we just get rid of all of those entries that are loading images. That's a really simple way to think about every time you look at any piece of information coming from a system, there's a lot of information there that is really unneeded for your purpose. So the data scientist has this, usually the domain expertise and the data expertise to understand how to look through that data, how to cull the data, and sift through it and then figure out just what the gold is. And then after they get the gold, then they can start writing the algorithms. Right, but after they get that gold, now they have some intelligence that we never had before on this data. So we need to work with them. We need to get the data scientists to share that intelligence, right, programmatically, systematically, to help us when we define this part. When we're graduating the data from the workspace to the big data warehouse, we need them to tell us exactly what they did to make it pristine so that we can make that process repeatable. So the non-data part of big data, right, it really talks about the people and the processes. There is in incubation right now a product called Falcon. I don't know if anyone in the room is familiar with it. Falcon, it's fairly immature right now, but I think it has some pretty good promise. And it will help you with the information lifecycle management of big data. In the meantime, what we're doing now is we're using things like Uzi and our own metadata tables to capture a lot of this information. Let's talk about master data management for a second. So master data management, it's all about unifying information coming from uncontrolled sources. Right? If they were all controlled, you would just tell them to do them all the same way and there would be no issue, right? So they're uncontrolled sources. When you have uncontrolled sources and you try to shoehorn them into a single unified structure, we've been trying to do this for decades. Anybody in the room have a successful MDM project? No. You can get really, really close, and you can just put scope around it and set expectations, and then within that scope and that expectation set, then you could be very successful. But it's really not going to do the job completely. One of the biggest challenges with MDM is the different hierarchies, depending on the different pieces of the business and depending on the different sets of how you want to look at the data. You know, for example, if you look at a provider could be a doctor, could be a group of doctors, could be a hospital, right? You could, depending on your definition, you could, you know, if you're doing like network adequacy for your organization, you can count that same doctor 1 time, 3 times, 2 times, right? So you really need to have clear definitions and be able to really understand your hierarchies within your organization for each master data management piece. So probably here it would be providers, members, agents, products, right? They all have their own sets of hierarchies. So we need to have a very flexible schema. We're finding that graph databases is a near perfect fit, and that relational databases are very, very awkward for this. Once we have that set, the inside is probably a graph database, and then we set a series of procedures around it. And each one of those procedures can have its own tool set. So for rules, you can actually use rules. You can use something we'll show at the end where you can dynamically use metadata to start manipulating your data. You have to apply security at all different levels within the hierarchy. You need to have a user interface so that when you have a data stewardship program, your users, your data stewards, can actually go in and correct some of this data, fix the hierarchies, fix the attribution of a provider or of a member. services so that you can start sharing it with other applications throughout your enterprise. And then this will become the data hub for all of your master data throughout the enterprise. So this is the way it was done old school, right? We would bring it in and we'd basically have a few libraries, validation processes, standardization processes, and then survivorship deduping processes. The hardest part was the standardization processes, right? When we're getting data from all different sources with all different sets of attribution, what do we do with all the gaps? And we would try to make it all look the same. What we're finding now, this is really the reality, right? Every single attribute can actually be its own entity, right? An attribute of a hospital could be the entity of a doctor's office, right? So we need to be able to stop trying to put structure on it and just start understanding it. And then we can apply rules around it. And the other thing that's interesting about graph databases is that the relationship itself is data. There's a few, Neo4j is a graph database. It's open source. You can go download it right after this and start playing with it. Pitney Bowes actually wrote a product called Spectrum. Spectrum MDM is a graph-based database that is an entire MDM solution. And then Reltio is, they actually have a graph database-based MDM solution specifically for healthcare. Let's talk about security for a minute. Even before big data, when I'm building data warehouses, just security is the thing you do last, right? Everybody shivers when you talk about security. In big data, it's even more difficult, right? How do you secure something that doesn't have structure around it? It's very, very difficult. So when we looked at the pyramid, on the bottom, basically what we're doing is we're just doing it at the file level. Either you have access to this file or you don't. It's not really till we start going to the top and we start applying structure to it. Then you can actually start applying more row level or even column level based security. There's a bunch of products that are being born today. Some are more mature than others. Cloudera Navigator is at least good for telling you who's seeing what. Sentry is actually a security mechanism, but Sentry only works with Hive so far. Knox, Hadoop, again, file-based. Data Guys is something that's very interesting. Data Guys is a product that does nothing but this. And they do masking encryption, and they, I think, are going to start getting recognized. They're a fairly new company. And then Datameer, which I mentioned earlier, Datameer is the BI tool right now that sits on top of Hadoop. So if you are exposing your data at the bottom in the data lake, if you will, to your users, if you go through Datameer, right, which speaks native MapReduce, you can actually apply a security layer within that product. Metadata within the Hadoop world, HCatalog. And then right now, today, there's really nothing that's like the total solution. Everything that is done, it has to be pretty much custom built at the moment. But we're not splitting atoms in this one. It's not that hard to build some metadata tables and load them up. Twitter actually, they're the trailblazers in this space. They actually, they could be said that they started the whole big data movement, or one of the firms that did, one of the companies that did. And they just, their data science team became the wild, wild west. And they said, this is insanity. We have to stop the insanity. So they created what they call the DAL, right, the data access layer. It's something that they built, homegrown, and it's really just it's more for the ILM, for the information lifecycle management. And it tells you exactly where the data comes from, what its dependencies are, who's consuming it, or what's consuming it, what schema can be applied. This is something that I hope soon that they make open source, that everybody could use it. Right now it only lives within Twitter. But hopefully this will give you an idea if you do want to roll your own. Something like this would be a great thing to do. And then data quality. As you're starting to present this data, we need to ensure to our data scientists and our data consumers that it is credible, right, certified data. So how do we do that? In the book that I wrote in 2004, I created what was known as the error event fact table. The error event fact table had a very special function in it where we had what was called a screen dimension. The screen dimension actually stores code that is executed every time you're ingesting new data. And you can there's two pieces. There's the actual screen itself, and then there's the action depending on the result. So you find it and you fix it, or you find it and you alert someone about it. Depending on what the severity is, you can have different actions. What we're doing now is we're actually taking this solution and we're putting it in the big data space. We're making a big data solution. We're going to put all of the tables in HBase and write the data quality engine in PIG. That's what we're thinking so far. And then once we do this, we'll make it open source so that we could share it and let people start helping us mature it. It's just about 1 o'clock. Closing thoughts. Polyglot persistence, right? Just be open-minded. Help enable the future. Blaze new trails. Get experts. To weed through this stuff, it's very, very exhausting. There's tremendous amount of information, tremendous amount of misinformation as well. Lots of claims. Find someone who's done it at least once. Right, save you a tremendous amount of time and pain and blood, and have fun. That's it. Thanks.